Welcome to this explainer. Today, we're diving straight into the absolute most bizarre, contradictory, and honestly extreme rocky world in our entire solar system. We're talking about Mercury. You know, it's a planet that really just shouldn't exist the way it does. And yet, there it is, stubbornly orbiting right on the very edge of our sun. So let's unpack exactly why this world is such a massive puzzle.
Let's start with a crazy hypothetical. Imagine a world where the sun rises, and by the time it actually sets, more than an entire Earth year has passed. I mean, it completely breaks our earthly understanding of time, right? But on Mercury, this isn't some science fiction concept. It is literally just orbital mechanics.
And the environment? Oh, it is brutal. If you were to somehow drop right onto the surface, you'd immediately be hit with temperatures soaring to a blistering 430 degrees Celsius. That is well over 800 degrees Fahrenheit. We are talking hot enough to literally melt lead. Sitting at an average of just 36 million miles from the sun, the solar radiation you'd experience there is absolutely punishing.
But wait, here is the huge contradiction. Because Mercury lacks a thick atmosphere to actually trap any of that heat, it just has this super tenuous exosphere of scattered atoms, the nighttime temperatures abruptly plummet to a freezing minus 180 degrees Celsius. It's wild. You basically go from a giant pizza oven straight into a deep freeze simply by stepping into the shadows. Talk about extreme, right?
Let's move into our first major topic, the bizarre illusion of time on this world. Let's look a little closer at those weird orbital mechanics we mentioned.
You see, for centuries, astronomers peering through their telescopes just assumed Mercury was tidally locked, meaning they thought it always showed the exact same face to the sun, kind of like how our moon behaves with Earth. But then, in the 1960s, this mathematical quirk was beautifully resolved by the brilliant Italian engineer Giuseppe Bepi Colombo. He actually proved that Mercury is locked in what's called a 3-to-2 spin-orbit resonance, so it rotates exactly 3 times for every 2 complete orbits it makes around the sun.
And this setup brilliantly illustrates the time paradox here. Because of this resonance, a single full day and night cycle, what we call a solar day, actually lasts for 176 Earth days. But meanwhile, a full orbit around the sun, which is a Mercurian year, only takes 88 Earth days. So yes, if you do the math, you heard that right, a single day on Mercury is literally exactly 2 years long.
Now, imagine standing on the surface. Mercury's highly eccentric, kind of egg-shaped orbit would play total tricks on your eyes. Because the planet whips around the sun at crazy speeds, up to 47 kilometers per second, its orbital speed actually briefly outpaces its rotation. So what does that mean for you? Well, the morning sun would rise, appear to completely stop, set slightly backwards, and then rise all over again. It's this incredible, bizarre celestial dance right there in the sky.
Moving on to our next section, let's talk about Mercury's giant iron heart and its abnormally massive core.
Just to grasp the scale we're dealing with here, if Earth were the size of a nickel, Mercury would be a mere blueberry. It is the absolute smallest planet in the solar system. And its surface gravity? That's only about 38% of Earth's. But here's the thing, despite its tiny size, it seriously packs a punch. It's actually the second densest planet in our entire solar system, trailing Earth by only a tiny fraction.
So you're probably wondering, why is it so remarkably heavy? Well, data from NASA's incredible MESSENGER mission reveal this abnormally massive metallic core. It takes up a whopping 85% of the planet's radius and 57% of its total volume. Just for some perspective, Earth's core is only about 17% of its volume. So Mercury is essentially just a giant iron cannonball wrapped up in a super thin, rocky shell.
This brings us to another huge puzzle, the magnetic mystery, and how exactly this little planet maintains an active dynamo.
Normally, small planets tend to freeze solid pretty quickly and just completely lose their magnetic fields. I mean, Mars is a great example of that happening. But surprisingly, Mercury still sustains an active magnetic field. How? Well, scientists believe this happens through a process called top-down crystallization. See, unlike here on Earth, where our core solidifies from the center outward, Mercury's metal actually solidifies near the core's ceiling, and then it falls downward as this bizarre iron snow. As this solid iron snow sinks, it churns up the liquid metal below it, and that churning action is exactly what powers its magnetic dynamo.
And to add to that, recent laboratory experiments suggest this churning liquid is actually insulated by a highly buoyant layer of iron sulfide. This layer acts perfectly as a sort of thermal blanket, and that beautifully explains how such a tiny world has managed to keep its core nice and toasty, keeping its magnetic field alive for almost 3.9 billion years. Okay, zooming back out to the surface, let's explore its scars, ice, and hollows, and take a look at this truly dramatic wasteland. Because make no mistake, the surface of Mercury is a violently scarred wasteland. First off, you've got the Caloris Basin. This is a massive 1,550-kilometer impact crater left over from the chaos of the early solar system. Then you've got these strange, bright depressions everywhere called hollows. We think these were left behind when volatile elements literally just boiled away into space. And maybe most incredibly of all, you have lobate scarps. These are giant cliffs that actually formed because as the planet's massive iron core cooled down over time, the entire globe physically shrank by up to 14 kilometers. It caused the crust to buckle and wrinkle, kind of like a drying apple. Now, get ready for one of the absolute greatest paradoxes in all of astronomy. Despite being completely baked by the sun at its equator, Mercury hides a freezing secret. Deep inside these permanently shadowed craters at its poles, the temperatures literally never rise above minus 180 degrees Celsius. And in those pitch-black depths, our probes have actually discovered thick deposits of water ice, covered over by dark organic material. So you have fire and ice existing simultaneously right there on the exact same tiny world. Mind-blowing.
So, how did this all happen? Let's dive into the ultimate origin puzzle and look at the leading theories for how Mercury formed. Right now, scientists impartially debate three leading formation theories to try and explain Mercury's unusually high metal content. The first one is called nebular drag. This suggests that the early solar winds basically pushed all the lighter rocks away, leaving only the heavy metal behind. The second theory is solar vaporization. This proposes that an extremely hot, early sun literally boiled off the planet's outer rock layers. And the third idea? A giant impact. Essentially a violently catastrophic hit-and-run collision with another protoplanet that just completely stripped away the original crust and mantle. To finally solve this massive mystery, the European and Japanese space agencies teamed up and launched the BP Colombo mission. It's actually named after the exact same mathematician who cracked Mercury's orbital resonance. The mission features two highly specialized probes that are scheduled to arrive in orbit in late 2026. They're going to map the surface composition and really dig into that magnetic field. So we are truly on the cusp of some brand new groundbreaking discoveries.
I want to leave you with this profound thought. While humanity will almost certainly never colonize this incredibly hostile world, the conditions are just way too extreme, unlocking the secrets of how this tiny iron anomaly formed is absolutely essential. It is quite literally the key to understanding the birth and the absolute extremes of all rocky planets, including our very own Earth. Think about it. If a planet this utterly bizarre can exist right next door to us, what other impossible worlds are just waiting to be discovered out there in the galaxy?